Okay, this is chapter 1.5. One of the other equations that are that can be turned into quadratic equations even though they don't look like them at first. So, for example, this one. What can we do? Can we simplify it? Can we get rid of those fractions? Go ahead and pause and take a look. Good. Hopefully you notice that this is an equation, which means I can multiply both sides by whatever I like, which in this case, I'm going to multiply both sides by x plus 2 and x minus 2, because that is my least common denominator, and that will get rid of all of these fractions. So, on this side, x minus 2 cancels out. I've got x plus 2 times x plus 5. Over here, I put parentheses because I have two terms. In the first one, x plus 2 will cancel out, and I'll be left with 5 and x minus 2. Over on this side, both of those will cancel out, and I'll be left with 28. Alrighty. No fractions. Isn't that sweet? So this is x squared plus 7x plus 10. This is 5x minus 10 plus 28. If I subtract 5x from both sides, I will be left with that. And then if I add 10, let's just simplify that first. This is plus 18. And so if I subtract 18 from both sides, this is what I end up with. And I think we can factor this by looking. That will get me negative 8 and plus 2x. So x is 2 or negative 4. Now, one big thing when we're dealing with a quadratic equation that came from fractions, you've got to think about domain. So over here, x cannot be positive 2 or negative 2. So we have to throw that solution out, and x is just negative 4. Here is another quadratic in disguise. What can we do? What can we do here? I've given you a tip here. If we can get the square root by itself on one side, we can then square both sides. So take a look. You can pause the video and see what you think. Good. So hopefully you subtracted 1. Well, why is that? If I have this whole thing and I square it, I'm going to have a bit of a mess. I'll have this, will get rid of my square root, because that's the idea. I don't want to work with that square root, so I want to transform it out of here. The problem is I've got this, and so I end up having square roots. Again, I didn't get rid of it. So instead, if I can get that, subtract 1 from both sides, now I have just the square root. Minus 2 minus 1 is minus 3. Now if I square both sides, voila! My square root disappears, and this side, I can deal with that square. And from here, just simplify, add x to both sides, subtract 5, and my answers are 4 and 1. Okay, again, because of where it came from, I don't have a fraction to worry about, but I've got a square root to worry about. And so I need to check and make sure that these answers are correct. 4 and 1. 5 minus 4 plus 1. Is that 4 minus 2? And yes, it is. My other one. 5 minus 1 is 4. Root 4 is 2. 2 plus 1, is that equal to 1 minus 2? No, it's not. So 1 is actually not a solution. Only x equals 4 is. Now, why is that? Sometimes when you square both sides, you can introduce another, an extra solution into the picture. Let's say I have a statement, which is that, let's do x equals 3. Right, that's what x is. Then I square it. X squared equals 9. Then I take the square root, and now I have x equals plus or minus 3. I just introduced a solution, the negative 3, that wasn't there when I began, and that occurred when I squared both sides. And so when you do that, which we have to do in order to solve it, we run the risk of introducing a solution that actually is not one of the original solutions. And so that's why, especially when you are squaring both sides, as we are here, we definitely need to check. Now this is a fun one. The key here is to use substitution. Let's take a look at this first one. We'll do the bottom one later. What are you going to substitute? How could you use substitution to turn this into a regular quadratic, something squared as the largest term? Go ahead, pause and see what you think. Well, if you decided to substitute for x squared, that is the way to go. So if a is x squared, then x to the 4th is going to be x squared squared. So now we have a squared minus 5, and x squared is a, plus 4 equals 0. Should look familiar. Okay, now we have solutions for a. A has got to be 4, or 1. But now remember, x squared, this means that x squared is 4, or 1. Those are our possibilities, which means x is actually 2 or negative 2, or 1 or negative 1. And so we've got those 4 answers. As we'll learn later, we could have as many solutions as we have degrees for the equation. So 4 answers actually fits this equation. Alright, so what would you substitute here? Go ahead and pause the video and answer that question. If you said, hey, let's let a variable stand for root x, you are correct. Because then x is b squared, and so we could substitute, oops, not x, b, plus 6. Now we have a quadratic equation with b. b minus 2, b minus 3 will give us positive 6, and minus 5b. And so then b is either 2 or it's 3. Now remember, that means that root x is either 2 or 3, and x then is either 4 or 9, right? just square both sides. Finally, these absolute value equations. Do you remember how to approach these? Do you remember why, even though they're not quadratic, they can have two solutions? How would we go about solving these? Go ahead and pause the video and see what you remember. If you said, hey, we can look at what is inside here, because this is either, right, either of those will give us 3. So either 2x minus 1 is indeed 3, or 2x minus 1 is negative 3, and we can solve each one of these. 2x is 4, or x is 2. And then for the second one, 2x is negative 2, or x is negative 1, right, if I add 1 to both sides. And so those are my 2 answers. Now this is a good lead into one of our coming units, which is looking at graphs. The reason that these also have 2 solutions is a quadratic equation is going to look like this. And so I have 2 places where that's equal to 0. Whereas absolute value equations look like a V, and so you could also have 2 solutions for those.